if I'm allowed to promote the type of variable based on what's happening inside of an equation, like we saw in a previous 3.3. Here in 3.5, and this is on page 103, we have type casting, where in line with our equation, we can typecast. We can tell C++ explicitly, treat this variable of type, whatever it is, as a variable of another type, whatever it is, and do what you're gonna do with it. So the example we have here, and I do want to tell you, you are going to see an example of this in the homework. I am not 100% convinced any longer of what question number it is. I looked it up before and I totally forgot. I need more coffee. So you'll see the example here. You'll type through essentially this example like you see right here on page 103, and that'll help you build a piece of muscle memory around it. But we'll just look at this little piece of code right here. So what I'm saying is I have a double, and I'm going to call that double number, and that number has a value of 3.7. I'm also going to have an integer variable. I'm going to call that val, and presently I do not have it assigned any value. I know val has no values. And right here on my last line, because I am going to, or what I want to do rather, is to say that val equals a static cast. So static underscore cast, that is you calling to this function that exists outside of things that we've already seen, but it is part of the IO manip and the standard namespacing that we're using. Static underscore cast, and here inside of the less than equal then, or less than greater than's rather, my mistake guys, is the type that you are expecting to pass, and then the number that you are going to give it. Okay, so what does that mean? So here on this line, we are going to suggest that, and you can see it right here in the code, that value equals, we have static cast, static underscore cast, all in lowercase. That is the function call that we're making. Please just leave that as a down payment. We will see function calls in chapter 6. We are making a call to the function called static cast, static underscore cast. And what we are going to do is cast as what you see in the middle of the less than and greater than, cast as an int, and then inside of those parentheses, we're going to pass to this function number. So let me break down what's happening there. This number here at the, towards the tail end of that line of code really represents this number here, my double variable called number. What I'm going to do is pass to static cast, which is a function. It's a formula. It's an algorithm, but it's an algorithm that I don't have to build. It's actually a portion of the standard C++ library here. And I'm going to tell C++, I want number, which is a double, to be cast here as an integer, so that when I save that over to the result of this over to val, which is my integer variable that I declared, I want it to be saved there as an integer. I know it goes a long way around the block, but there are times where inline mathematically we want to force one type of variable to be interpreted as another. So if we want to escape some of those foibles of integer mathematics when we're doing integer division, but we do still have double numbers there, we can static cast all of our integer types as double, just as long as that equation is being computed or computed. So when that computation is done and that value is stored out to our, potentially to a variable, but potentially just as an output in my, in my output window, that I don't have to worry about the foibles of integer division, int. I can just cast everything in line as double and avoid any of those pitfalls. I know you haven't seen enough yet with, math and with C++ in general for that to make sense, but it's here in the chapter. I promise we'll see it. And then later on down the line, one or two times in chapter 5 and a couple of times in 6, you're going to be glad that you filed this way in the back under might use it someday, because you are going to use this someday.